Welcome back, guys. In the last few videos we discussed the working of a PN junction diode and its application as a rectifier. Today we'll have a look at the bipolar junction transistor, or simply transistor. So first of all, what is a transistor? A transistor is a semiconductor crystal whose two sides are extrinsic semiconductor of the same type, either NN or PP, and the middle portion is of the other kind. And thus a transistor can be of two kinds, NPN or PNP. And the two outer elements are called the emitter, denoted by E, and collector, denoted by C. And the middle one is called the base, denoted by B. The same in the PNP transistor. And the invention of transistor was another giant step forward in terms of technological advancements. And William Shockley first invented the junction transistor in 1951, and this transistor has led to many other semiconductor inventions, including the integrated circuits. And because of these integrated circuits, modern computers and other electronic miracles are possible. The emitter is heavily doped. On the other hand, the base is lightly doped, and the doping level of the collector is intermediate between the heavy doping of the emitter and the light doping of the base. And the collector is physically the largest of the three regions. Now here in the diagram also I have made collector the biggest. It may not be very apparent, but if you zoom in and try to see it properly, I guess you'll see it. And the size of each region also indicates the doping levels. Okay, and it's very clear that the transistor here has two junctions, one between the emitter and the base, and the other between the collector and the base. Because of this, a transistor may be regarded as two diodes joined back to back, and these two diodes are called emitter diode and collector diode. And obviously the two depletion layers that will be formed will not be of equal width because of the difference in the doping levels. And this is the symbol for PNP and NPN transistors. Okay, here N stands for, in Nepali, Niskyo, because it's pointing outward. Okay, and P stands for Pasyo, because the arrow is pointing inwards. Okay, so this is the symbol for NPN and PNP. Now let us have a look at the working of a transistor. First, we'll have a look at the working of a NPN transistor. Okay, the figure here shows how a transistor is biased for its normal operation. We see that the emitter base junction is forward biased and the collector base junction is reverse biased. When VBB is greater than the emitter base barrier potential, emitter electrons will enter the base region, and theoretically these free electrons can flow in either of the two directions. Number one, down the thin base to reach the positive terminal of the battery, BBB, or into the collector region. But which way will the free electrons go? Most will continue on to the collector. Why? Because of the two reasons. The base is lightly doped and it is very thin. The light doping means that the free electrons have a long lifetime in the base region, and very thin base means that the free electrons have only a short distance to go to reach the collector. For these two regions, almost approximately 99% of all the emitter injected electrons pass through the base to the collector. Only a few electrons will recombine with holes in the lightly doped base. Then, as valence electrons, they'll flow to the positive terminal of the battery VBB, and this recombination produces the base current IB. Obviously, this IB is very small, and almost all the free electrons go into the collector, and once they are in the collector, they feel the attraction of the VCC source voltage, and because of this, the free electrons flow through the collector until there is the positive terminal of the collector supply voltage. Because of this movement of electrons, we have the collector current denoted by IC, and obviously IC is very much larger than IB. And if we apply Kirchhoff's law, it's very simple plain logic that IE will be equal to IB plus IC. Now let us see the corresponding circuit for a PNP transistor. The action of a PNP transistor is almost the same as discussed for NPN transistor. The only difference is that the majority carriers flowing within the transistor are holes. And guys, if you are finding this series interesting and helpful, consider subscribing to my channel for more future updates in physics and other areas. That's it for today, guys. See you in the next lecture.